Hi folks, in this video I'm going to provide the answer to question 34, and this is worth 4 marks. An aqueous solution of ammonia is added to a solution containing hydrochloric acid. A plot of conductivity against volume of ammonia solution added is shown. The temperature of the solution is kept constant throughout, and the conductivity of the solution is corrected for dilution. Explain the shape of the graph, including 2 balanced chemical equations in your answer. So the whole point of this exercise is to look at the graph and identify each portion what you think is happening. The other thing we need to understand is the relative conductivity of these different items. So we're going to start off the understanding from here, progress to the equivalence point, past the equivalence point. So this will be our whole journey. According to the sample answer, this is what it says. Before the equivalence point, hydrochloric acid is being neutralized by the added ammonia. Ammonia is added to hydrochloric acid. It makes sense that the conductivity decreases. As ammonia is added, ammonium is produced, and that in effect replaces the H plus particles in the volume. The conductivity decreases, NH4 is increasing, H plus decreases. After the equivalence point, the excess ammonia added will produce ammonium plus and hydroxide ions, both of which have greater conductivity than the reactant molecules. The reaction only occurs to a small extent. However, as the ammonium already present in the solution will suppress the ionization. In the teacher's answer, I go a bit further. This is the HSC sample answer. Here I show you how equation 4 is derived. So first, the question begins the story with hydrochloric acid. We know hydrochloric acid is a strong acid, so we know that it fully dissociates into the hydronium ion and the chloride ion. This is the conjugate acid. This is the conjugate base. This is where equation 1 exists. When the weak base is added to hydrochloric acid, ammonia with water goes to conjugate acid and conjugate base. Equation 2 is added to equation 1. Equation 3. We see chloride ion 2H2O occurs on both sides. We can rightfully cancel it out. Equation 4 is derived. So according to HSC, the reason why conductivity decreases, it can be said that the conjugate acid of the ammonia replaces H plus ion, leading to a decrease in conductivity. Now if you look at my equations, the reason hydrochloric acid decrease in conductivity over time is because as ammonia is added, it generates hydroxide. When reacted with H plus makes water. That's where the neutralization happens. One should expect that stoichiometrically, the mole of H plus is now the same as the mole of hydroxide ion. Past the equivalence point, we're adding more ammonia. So it's going to have the effect of the rise in conductivity because hydroxide has a larger relative conductivity than both ammonium and chloride, and that is why it slightly increases the conductivity. However, since the conjugate acid is already present and the fact that it also produces more conjugate acid, it's going to react with the hydroxide ion and effectively pushes the equilibrium to the left. So this agrees with the HSC sample answer. Thank you for watching, and I'll see you next time.